The funding call was deliberately aimed at developing or initiating relationships with community organisations. So I thought it would be ideal to continue our work with Blesst. I had an idea for some science that I thought kids in Blesst could be involved in, and what I wanted to do with this was that this wasn't going to be some kind of pared down simplification of stuff that we already do. This is genuinely new science. We started this with thinking about links to air quality. It's a big deal in cities. It has huge impacts in health. And it may not yet actually even, if you breathe in poor air over a long period of time, you can get ill. And in some cities, the air is of such poor quality, it may not even be that long. So that's the kind of the driver for this effort. That's why we want to understand this.
We want to know from the lamppost, we're going to take from, I think it's from here to your belly button, they swab it down and they collect the dirt off it. That dirt's going to be taken to a lab to see how much air pollution there is around in all the areas. So that's actually what the project they're doing. So while I set up, they're going to go for about half an hour, just on the edge of town, because we've done all this area around here. So they're going to go on the edge of town, do their swabbing. So the project's called Street Grime.
Essentially, the strategy that they had to use in the sampling was to use lamp posts as a surface where all those pollutants have been accumulating, and to use those to collect dust and particles out of those lampposts.
So today we are experimenting and collecting data for the project Street Grime, and we're going around different streets of Birmingham, specifically in the city centre, and trying to collect pollution levels from lampposts and other smooth surfaces and calculate how much metal there is in that sample, so we can see the levels of pollution within the clean air zone.
So the challenge was, how do we collect that in a systematic and uniform way so that we can compare? And yeah, it was a wet swab, so a cotton wool swab. We used deionized water, so we're trying to pick a medium that doesn't have its own magnetic signal. So cotton swabs will be slightly negative, but not enough to disturb our results, and deionized water should be neutral. So normal water may already have a little bit of magnetic material in there already from tap water. Deionized water is neutral. So we have a swab, deionized water, and then we collect a uniform. We tried to pick a meter, but having a meter stick was cumbersome, so we just said to the kids, from above your head to your belly button.
Let's say the benefit of this project is that it's relatively quick. So you can really go out and one day come back in the lab, the next day measure the samples, and pretty much in 2 days you will have some sort of data.
We have to get our cotton swab, our cotton ball, and with distilled deionized water, we wet the cotton swab, and with the same measurement, so like a meter, we swab down the lamppost and we collect that information in here. So this is a swab sample. And then we write down the date, the time, and our initials, which we will then tag on Google Maps as a location, so that we could put all the tags together and then ultimately see a pattern within England or Birmingham.
What's this? EC 04.
Yeah, 03.
03. And this is Shadwell Street.
The biggest thing that I've learnt is how to make it a controlled test properly. Basically, if you don't do it in the same way each time, the result's going to be different, so it's about controlling your tests. Which one next? We could do that one. I found it good. It's quite interesting to do it. It's kind of like doing a science experiment, but being out on the road.
I think it's really educational, and it kind of allows you to open your eyes a bit, because you say that Birmingham has high pollution rates, but you never really think about it that much, so it's kind of eye-opening.
I think it has quite a big problem with pollution because even looking at studies, it says that air pollution is probably one of the top causes for late onset asthma for adults and children in Birmingham.
There are many sources. One, of course, is the exhausts. So fumes coming out of cars and other vehicles, they contain the particles, so the PM10 and PM2.5. And other sources are the brakes, the brake pads. So as soon as the car, stops, they consume the brake pads, and those particles just fly out in the air, and they can get deposited over surfaces, which we have used for this project to measure. Other sources are even coming from far away, for example, from the Sahara Desert. So there are several kind of, I can call it waves of that material. There's not a constant delivery from Sahara Desert, but they can come occasionally, and they contain hematite, which is a particular magnetic mineral, and has been tracked down here in the UK. Hematite over surfaces, over trees, over everywhere, every surface is basic, and the only source for that has been demonstrated to be the Sahara Desert.
This was the sampling that the kids from Blesst did, so much more detailed street level stuff. And here's what we did in the lab. The university is an anchor institution in this city. It has a role, it has a responsibility in this space to support and develop young people as well as students, and as well as being an employer. So what I'm trying to do is work out how that looks. And that was really the driving force behind this. So this is what we trained kids on, and this is the susceptibility. It's called the Kappa bridge, is the formal name for it. But this is this idea where you have a magnetic field, you put a sample in the field, and this thing can pick up how that field changes. Sample number. You all got sample numbers on the bags, so.
Yeah, did you do that? We did, didn't we?
Yeah, you got. We talked about all that. So.
We did do samples on the bags, didn't we? Yeah. What else did you do on the bags?
The date, the name, and the street.
And the code. There was a code as well.
The location.
Yeah. Location.
So what we're going to need to write down here is you got sample number, location, and it doesn't save it on here, so we literally just write it down. Sophisticated stuff. Location, and then the actual measurement. Put the sample in the holder and press F1 to make the measurement. That's all you need to do. Think you can do that? Over to you. Okay, so yeah, pick up a sample. That's it, there you go, you can tighten up the screw. That's it there. It's really straightforward to use. We weren't dialing back on the method, so what the kids at Blesst did was exactly what our masters and PhD students are doing.
It's opened my eyes a lot to how university research would be take place, and I think it's quite interesting, to be fair.
So what I'm trying to do here is to kind of expose kids to this place, to come inside the door and see what the halls are like see the people, meet the people. We're all humans, and this space it's just like any other place. You won't combust as soon as you walk in the door. But I wanted to give them that access just to see what it's like. So it's not as unknown or scary, and demonstrate that it's possible as well. I mean, the action here is partly on providing that access, providing that exposure to the kids, so it's less scary, less intimidating. They may consider it, they may not, it doesn't matter, but they still understand what goes on. But it's also on this world as well, to demonstrate that you can do this in a way that you don't have to pare it down, simplify it, or dumb it down. This is genuinely novel science. These are the susceptibility results. And you don't need to understand the detail of the numbers other than these circles. The bigger the circle, the higher the susceptibility value, which means the more iron, and according to our assumption, the more pollution. So the bigger the dot, the more pollution, essentially. And what we're seeing is a very clear trend. So over in the east, we're seeing bigger dots. Now there's a few point anomalies where there is a real spike. And in the statistics you can see it sits as a spike, but it's not a surprising spike. It's where we're seeing a bigger trend anyway. Now the interpretation, it could be, in the UK we have prevailing westerly winds, so it could be the wind blowing pollution to the east. But we also know there's a lot more industry in the eastern side of the city. The long and short of it is the susceptibility tracks with what we'd expect from the distribution of pollution. So it kind of works, is the long and short of it.
It's actually excellent. I mean, we think that really involving people, especially young people, into this kind of a study has many benefits. So first of all, they may, trigger some interest in science, which is great, The second is actually they also trigger some interest in the environment. They might not be aware of what the environment looked like around them. They might be just assuming it's good quality, everything is good, but actually measuring, firsthand how the place where you're living look like in terms of safety. I think that's a big, it's quite a positive impact in the kid's life, I guess.
So this is actually breaking new ground. The data we would collect would be genuinely novel, and the findings would have the same risks and uncertainty as doing stuff for the first time. So what we have got, the data we have is brand new data.